Let's solve this problem. Several capacitors are connected as shown in the figure. If the charge on the 5 microfarad capacitor, that is this one here, is 120 microcoulomb, what is the potential between point A and point D? That's what we have to find out. The potential between A and D is the same as the potential across this capacitor. So the question is, what is the potential across 30 microfarad capacitor? We are going to use two facts to find out the potential across 30 microfarad. So the first one is, if two capacitors are connected in parallel, the potential across them is the same. If two capacitors are connected in series, the charges stored in them are the same. So let's use this and then find out the voltage across 30 microfarad. Now, first of all, what is the potential across this? Since all these three capacitors are connected in parallel, the potential across them is the same. So let's first find out that. For that, we are going to use the clue given in the question, that is, the charge stored in 5 microfarad is 120 microcoulomb. We know C equals Q by V. So what we want is voltage across 5 microfarad. So V equals Q by C. Q is 120 microcoulomb and C is 5 microfarad, which is equal to 24 volts. So the voltage across this combination is V equals 24 volts. Now to find out what is the voltage across this 4 microfarad capacitor, we are going to use the second fact, that is, the charges stored in them is the same, because all the three capacitors are connected in series with 4 microfarad capacitor. So what is the charge stored in the parallel combination? So Q equals the combination capacitance of the parallel capacitors multiplied by the voltage across them, which should be equal to 4 microfarad capacitor times the voltage across 4 microfarad capacitor. So what is the CP here? That is, since all the 3, 5 and 4 microfarad capacitors are in parallel, it is actually 3 plus 5 plus 4 microfarad. So micros and all will get cancelled, so we don't have to use that at all. So here voltage across them we have already found out, it is 24, which is equal to 4 times what is the voltage across the 4 microfarad capacitor. So let's solve this. We will have here this will become 6, 8, 12 into 6, which is equal to V4, which is equal to 12. 72 volts. So what does it mean? We have found out the voltage across the 4 microfarad as 72 volts. So what does it mean? The potential between these 2 points is now 72 plus 24 equals 96 volts. So that is the same between these 2 points here. That is 96 volts. Now we are going to apply the same technique for this part of the circuit now. Okay, so let's do that. Four microfarad here and 2 microfarad, these two are in parallel. So the charge stored in them is different. The potential across them, it should be the same. And it is in series with the 30 microfarad. So what is the charge stored in 30 microfarad? It is 30 microfarad times the voltage across the 30 microfarad, that is the voltage difference between A and D, is equal to the parallel combination Cp here multiplied by the voltage across 2 and 4. Now we know that it is the total voltage difference between them is 96 volts. Then I can write this as Cp times 96 minus VAD. That is the voltage across the 30 microfarad. Good. Now we have to find out 30 microfarad VAD equals, what is Cp here? Cp is the uh, combination capacitance of 4 and 2, since these two are connected in parallel. So 4 plus 2 is 6. So 6 microfarad times 96 minus VAD. Micro will go away, and this will become 5 now. Okay, so 5 VA, here it is D, VAD equals 96 minus VAD. Now let's solve for VAD. That is 5 VAD plus VAD equals 96, which gives us 6 VAD equals 96. Then we get VAD equals 96 by 6, which gives you 16 volts. So the voltage across 30 microfarad, or the voltage between point A and point D, is 16 volts. That's it. Thank you.